Bismillahirrahmanirrahim. This is Ghulam Rasool, and I have to present the topic of SPI serial port in AVR microcontrollers. So, the introduction of the serial peripheral interface is a bus interface connection protocol originally started by Motorola Corporation. It uses 4 pins for communication: SDI serial data input, SDO serial data output, serial clock, and chip select. So it has 2 pins for data transfer called SDI serial data input and SDO serial data output. Serial clock pin is used to synchronize data transfer, and master provides this clock. Chip select pin is used by the masters to select the slave device. You can see this is the serial ports in AVR microcontroller. There are PC, USART, SPI, devices, sensors, switches, LCDs, sensors, LEDs, motors. So different types of serial ports in AVR are shown in this picture. Serial ports in AVR. Previously, USART and old and widely used standard pins 14 and 15 of 80 mega 32. So now the basic SPI serial peripheral interface, very high speed, 2 orders of magnitude faster than USART synchronous serial port. For example, for high speed data transfer to a from pin 5 to 8 of 80 mega 32. SPI wirings are uses only 2 pins for data transfer: SDI DIN data in, SDO data out. Requires a shift clock pin to synchronize the data transfer. Require a CE chip enable pin used to initiate and terminate the data transfer, called masters output and masters input, clock, serial clock, and SS in AVR. 3-wire SPI. There are alternative the 3-wire interface bus, SCLK and CE, and only a single pin for data transfer. The SPI 4-wire bus can become a 3-wire interface when SDI and SDO, data input and data output pins, are tied together. So this will convert into 3-wire SPI. This is the basic SPI architecture. Data bus transfers into SPI shift registers and into clock generator. So 2 8-bit shift registers, one in the master and other in the slave side. A clock generator in the master side generates the clock for the shift registers. The connection serial out pin of the master shift register to the serial in pin of the slave shift register by masters out slave in method. Serial in pin of the master shift register to serial out pin of the slave shift register by master in slave out pin. After 8 clock pulses, the content of the 2 shift registers are interchanged. So the slave select pin of the SPI buses is used to select the slave to initiate and terminate the data transfer. Makes sense in devices connected to several slaves. In master mode, slave select when slave select is 0 to enable slave, and when we have to disable slave, we have to select 1. So they are actively low, and this is some method which is used in this diagram. So the SPI registers in AVR: SPI SCR status register, SPI CR control register, SPI DR data registers. This is the SPI serial clock frequency, which is different types of when we have any program or when we have any data to transfer. These are the frequency rate which we can connect our program. So the SPI operation can be used for simple data transfer. Just write data to SPDR. 8 clocks are generated automatically to transfer data. Slave can never start sending data. Standard mechanism for masters to read and write data from a memory address. First send address and also tell if the transfer is read or write, then send receive data. These are some steps for reading data from SPI devices. Single byte, we can make 0 to begin reading. The 8-bit address is shifted in 1 bit at a time with each edge of a clock, and at 870 we can read operation. After After 8 bits of the address are sent in, the SPI device send out the data belonging to the particular location. The 8-bit data is shifted out and 1 bit at a time with each edge of select. So the make CE to introduce the end of the read cycle. As well as we have a step for writing data from SPIs. We can use these steps to write the data in the SPI device. So the SPI programming in C, this is a simple and AVR program to initialize the SPI for master with clock frequency which is equal to first L6 and then transmit G via SPI repeatedly. The received data should be displayed on port A. So you can see SPI 12 is these are the ports which are used and the frequency we have used. So SPI programming in as we can see, the received data should be placed on port A. We have include AVR library define MOSI 5 DDR we have used, which is 1 is less than or equal to master's output and a serial output, and we have used the SPDR and which have data. MOSI and SER output, port A is output and we have enable SPI as a master. We have start transmission, wait for the transfer, finish, move, receive data. We have received data on port A. So this is also the AVR program to initialize SPI for slave and clock frequency for sec4 by then shown the received data on the port D. So this is the MISO as output, other pins output, and port D as outputs. We have DDRD and we have enable interrupt, enable SPI clock frequency 1/4 SPRC system. So this is the data which we will be shown on the port D. SPIs in PCs, so basic input output systems. The first software run by PC when powered on was the SPI. Initialize and test the system hardware components and to load the bootloader or an operating system. So BIOS is stored on programmable ROM. The ROM is connected to a south bridge of motherboard by SPIs. So this is the LPC interface. Before SPI, LPC used to adopted to connected the BIOS. LPC low pin count bus. Before 2016, BIOS used to connect it to south bridge through the LPC interface. Now some laptops uses LPC for BIOS, a 7-wire bus. So this is the basic of SPI and the basic information which I have given in the presentations. So thank you so much.